There are different applications of linear equations, one of which is number-related problems. This video shows different examples for such problems. Welcome to Mathematics of Engineering. In this video, number-related problems discussed are about digits, and careful interpretation is required. The succeeding videos will show real-life situations. Each of these problems will be solved in detail. Start with the first problem, stating a number increased by 7 is equal to 47. What is the number? Let's assign x for the unknown number. Interpret the problem algebraically as x plus 7 as equal to 47. Transpose 7 to the other side and simplify to have x as 40. The second problem states twice the number is 500, more than 6 times the number. What is the number? Again, assign x as the number required. Interpret the equation as 2x as equal to 6x plus 500. Transpose 6x to the other side and have negative 4x as equal to 500. Divide both sides by negative 4 to have x as negative 125. The next problem has the sum of 3 consecutive integers is 42. Find the 3 integers. With 3 integers unknown, we let x be the first integer. The second integer is assigned as y, then z is the third integer. Consecutive means the integers are just one number next to each other. So the second integer y is just x plus 1. And then z is also y plus 1. However, we just mentioned that y is equal to x plus 1. Substitute this expression into z and have z as x plus 2. For the working equation, we have the sum of the integers as 42. That is x plus y plus z as 42. Since we only have one equation, we should convert all variables x, y, and z into a single variable x. The equation then becomes x plus 1 plus x plus 2 as equal to 42. Simplify the terms and arrive at 3x plus 3 as equal to 42. Transpose the constant 3 along with 42 and arrive at 3x as equal to 39. Divide both sides by 3 and get x as 13. Having identified x, we can then look for y and z through substitution. Y is identified earlier as x plus 1, so y is 13 plus 1 to have y as 14. Then z is x plus 2, where x is solved as 13, making z as 13 plus 2, giving z as 15. Problem 4 asks for two numbers whose sum is 68 and whose difference is 22. Assign x as the larger number and y the smaller number. From the problem, the summation of the numbers is identified as 68. We write this algebraically as x plus y is equal to 68. This is equation 1. The other equation is their difference. That is x minus y as 22. Take this as the second equation. Given two equations, we retain the two variables and use the method of elimination to find one variable. Add x plus y as 68 with x minus y as 22. When adding these equations, y cancel out, making 2x as equal to 90. Isolate x by dividing everything by 2 and get x as 45. With x already known, y is solved by plugging x into equation 2. That's 45 minus y as 22. Transpose 22 and negative y, making the equation 45 minus 22 as y. Simplify the constants and have y as 23. The fifth problem states the sum of two consecutive even integers is 94. Find the numbers. Assign x for the first even integer and y for the second even integer. We still have consecutive numbers, although this time they should be two consecutive even numbers, which means their interval is 2. So y is then equal to x plus 2. The problem also states that their summation is 94. We write this as x plus y as equal to 94. With only one given equation, transform terms into a single variable, so we use y as x plus 2. The outcome is simplified as 2x plus 2 as equal to 94. Group all constants together to get 2x as equal to 92. Divide everything by 2 and get x as 46. This is the first even integer. Now we can compute for y, which is just x plus 2. Plug x as 46 to get y as 48. For problem 6, the sum of three numbers is 58. The second number is 4 more than the first number, and the third number is 8 more than the second number. What are the numbers? Assign x for the first number, y for the second number, and z for the third. From the problem, the second number y is x plus 4. Also from the problem, the third number is 8 more than the second, that is z as y plus 8. With y already identified as x plus 4, z then turns into x plus 12. The equation stating the summation of numbers is also identified, that is x plus y plus z as 58. With three unknown variables, it will be impossible to have this solved with just one equation. So we convert y and z as x. We get x plus y as x plus 4 and z as x plus 12. And they are all equal to 58. Simplify the terms and get 3x plus 16 as equal to 58. Transpose constants and get 3x as equal to 42. Divide both sides by 3 and get x as 14. This is the smallest even integer. The second integer is x plus 4. That is 14 plus 4, which gives y as 18. Then the last integer z is solved as x plus 12. Again, x is 14, so z is computed as 26. The seventh problem states the sum of two consecutive integers is 65. Find the two numbers. With two unknown numbers, we assign them as x and y. To make these integers consecutive, their interval is 1, making y as x plus 1. The sum of the two integers is also given in the problem, that is x plus y as equal to 65. With y as x plus 1, we get the equation as x plus 1 equal to 65. Collect similar terms and get 2x plus 1 as 65. Transpose 1 to the other side and have 2x as 64. Divide everything by 2 and get x as 32. This is the first integer. The second integer is then solved as the first plus 1. That is 32 plus 1, which gives y as 33. With problem 8, separate 84 into two parts such that one part will be 12 less than twice the other. With two unknown parts, assign x as the larger part and y as the lesser part. Identify the relationship of x and y as it is placed in the problem that x is 12 less than twice of y. Another information given in the problem is the equation of the summation of parts to be equal to 84. This makes x plus y as 84, where x is converted into 2y plus 12. So simplify terms and get 3y minus 12 is equal to 84. Transpose 12 and get 3y as 96. Divide everything by 3 to have y equal to 32. Next is to solve for the larger part. From x as 2y minus 12, x is then twice of 32 minus 12, where it becomes 52. The next problem states, if 6 times the number is decreased by 6, the result is the same as when 3 times the number is increased by 12. Find the number. This only has one variable assigned as x. The problem can then be translated as 6x minus 6 as equal to 3x plus 12. Collect similar terms and place them in opposite sides of the equation. So 6x minus 3x is equal to 12 plus 6. 3x is then taken as 18. Isolate x by dividing everything by 3 and have x as 6. For the last example, if 3 times the number is increased by 22, the result is 14 less than 7 times the number. What is the number? Let x be equal to the number. From the problem, we get 3x plus 22 as equal to 7x minus 14. Transpose terms and collect them to have 3x minus 7x as equal to 14 minus 22. Simplify them to get negative 4x as equal to negative 8. Divide both terms by negative 4 and get x as 2.